Okay, moving on to veins. Veins have a greater capacity for blood containment more than arteries. They have much thinner walls. They are less muscular. They are collapsed when empty, but they do expand easily. And they have a steady blood flow. So arteries are more kind of a surge as the heart beats, whereas veins are more of a steady blood flow. They do merge together to form larger veins. So for arteries, we kind of went from biggest to smallest. For veins, we're going to start with the smaller veins and work our way up to the bigger ones. They are subjected to a relatively low blood pressure, so they don't have to have that thicker wall that can sustain that pressure. This shows kind of where the blood would be at any given time. 70% of the blood is in the systemic circuit. Of that 70%, 54 of it is in the veins, whereas then you can see the arteries and capillaries only at 5% and 11%. So most of our blood, half of our blood at any point, is in the veins. Okay, so we're going from smallest to largest. So the smallest veins are called postcapillary venules. This is when the blood is leaving the capillary beds. It empties into these smallest veins. They are more porous than capillaries, so they are also exchanging fluid with the surrounding tissues. Now, we almost always think about the capillaries doing the exchange, but some of these smallest veins can do the same thing, but the capillaries are doing it more, so we usually talk about them doing that process. But some of the smallest veins can do that as well. These venules have the tunica interna with just a few fibroblasts, but no muscle fibers around them. Most leukocytes, the white blood cells, which we will get to when we get to blood, emigrate from the bloodstream through these venule walls. So if the white blood cells are needing to go to a certain location, they are going to go through the venule walls instead of through the capillary walls. Okay, again, going from smaller to larger, so the next step would be a muscular venule. They can be up to 1 millimeter in diameter. So they have 1 or 2 layers of smooth muscle in that tunica media and still have a thin tunica externa. Getting larger from there, the medium veins can be up to 10 millimeters in diameter. They have a thin tunica media but a thicker externa, and they also have venous valves. The varicose veins can come from failure of these valves. So these valves not working can lead to varicose veins. Skeletal muscle pumping propels the venous blood back to the heart. Okay, some veins with very thin walls would be the venous sinuses. They have large lumens, that's the opening of the vein, but no smooth muscle. Some examples would be the dural venous sinus and the coronary sinus of the heart. They are not capable of vasomotion. Then the large veins, the largest, should say, larger than 10 millimeters. They have the smooth muscle in all 3 layers. This is when we see the vena cava, the pulmonary veins, the internal jugular veins, and the renal veins being the largest. You'll see these when you dissect. So varicose veins can happen because of blood pooling in the lower legs, people who stand for long periods of time. The cusps of the valves pull apart, and they make the veins even weaker when that occurs. So blood will backflow and further distend the vessel. The walls grow weak and develop into varicose veins. This can be hereditary, but also comes from obesity and possibly pregnancy. Hemorrhoids are varicose veins occurring in the anal canal. Okay, we're going to look at circulatory routes, and then we're going to leave that as the end of this video and have blood pressure in the next clip. Most commonly, the simplest route would go from the heart to the arteries, arterioles, capillaries, venules, veins, and then back to the heart. We would expect most blood to just pass through only one network of capillaries or one capillary bed. And so you can see that in part A of this picture. But there are other occurrences, and we'll get into those as we continue through this chapter. A portal system is when there's two capillary beds. The blood will flow through the first one and then a second one before it moves back to the heart. And then we can also talk about times when blood basically bypasses a capillary bed, and one of those being a shunt. So portal system is when it goes through two consecutive capillary beds. We see this in the kidneys. We can see this up by the hypothalamus and the pituitary, and also in between the intestines and the liver. Okay, so sometimes the capillaries are basically bypassed when two blood vessels are merging. We can see this when artery flows directly into the veins as a shunt, or when one vein empties directly into another, and that would be more common. Two arteries can also merge. This provides a collateral or alternative route of the blood supply to a tissue. We see this in coronary circulation. We talked about it in that heart anatomy video, and we also see this around joints.